So let us look at the next example using reference angles to evaluate functions. We need to evaluate tangent of negative 240 degrees. So the first thing I'll do is I'll rewrite the tangent negative 240 degrees as negative 180 degrees minus 60 degrees, which would actually give me negative 240. So I start on the x-axis and I go first 180 degrees in the negative direction and I go another 60 degrees. So I'm going to land in quadrant number 2. So my terminal side is going to be in quadrant number 2. So the next step for me to do is figure out that reference angle. So my reference angle is going to be 60 degrees. So the reference angle is a 60-degree angle. So I am going to make my right triangle here, which is going to be my 30 degrees, my 60-degree angle. And then here I have my hypotenuse is 1, my shorter leg is a half, and then my longer leg is √3/2. So this special right triangle you can see again on the bottom of the page of your unit circle. And then from here I need to evaluate tangent of 60 degrees. So tangent of 60 degrees, because 60 degrees is my reference angle. So I'm going to write it down, reference angle. So I need to figure out tangent 60, which is going to be opposite over adjacent. So the opposite to the 60 is √3/2 divided by the adjacent side is 1/2. So the answer here is going to be √3/2 times 2/1, because dividing fractions is multiplied by the reciprocal. And if I simplify, I just get tangent 60 degrees is the square root of 3. Last, I need to decide in quadrant 2 if tangent is positive or negative. I know that tangent in quadrant 2 is going to be negative in quadrant 2. So finally, the answer is for tangent negative 240 degrees is going to be negative square root 3. So I followed every one of the steps that was required to figure out the value of tangent negative 240 degrees. Our second angle is cosecant 17 pi over 6. So again, I'm going to start out by rewriting it, and I'm going to say cosecant 12 pi over 6 plus 5 pi over 6. So if I'm looking at 12 pi over 6, that's basically an entire circle, because that's going to be 12 divided by 6 is 2 pi. So I'm going in the positive direction. I'm going to go an entire circle. And then from there, I still need to go 5 pi over 6, which is almost pi. So I'm going to go 5 pi over 6. So my terminal side of the angle is going to end right here. So that means my reference angle is going to be pi minus 5 over 6 pi, or 5 pi over 6. So 6 pi over 6 subtract 5 pi over 6 is going to give me a reference angle. Theta prime is 1 pi over 6, or just pi over 6. So again, pi over 6 is, if I convert that into angle measures, 180 divided by 6 is 30 degrees. So I'm going to have to use my special right triangle again. That is the 30, 60, 90 right triangle. So I created it for the second time. And I'm going to say this is the shorter leg is 1/2, the hypotenuse is 1, and square root 3/2 is going to be my longer leg. The cosecant function is going to be radius divided by y, because it's the reciprocal of the sine function. So our radius is going to be 1, and then our y value is going to be, well, let's go ahead and figure out first our sine theta. So sine theta would be y over r. So our sine pi over 6 is going to be the sine of 30 degrees, which is 1/2 divided by the radius is 1. So in other words, it's just going to be 1/2. And then cosecant pi over 6 then is going to be the reciprocal of that, which is 2. So cosecant pi over 6 is going to give me 2. So now I need to decide if that is going to be a positive or a negative 2, because we are in quadrant 2. So cosecant in this quadrant is going to be positive. So my final answer is going to be cosecant 17 pi over 6 will have a value of 2. Problem number 5, or example number 5, is going to be a real life problem. The horizontal distance d in feet traveled by a projectile launched at an angle theta and with an initial speed v in feet per second is given by the equation d equals v squared divided by 32 times sine 2 theta, which is the model for horizontal distance. Estimate the horizontal distance traveled by a golf ball that is hit at an angle of 50 degrees with an initial speed of 105 feet per second. So let us identify the variables. The 105 feet per second is going to represent our initial velocity. Theta is going to be our 50-degree angle. And that's it, what we need to do, or we need to have in order to calculate the horizontal distance. So the horizontal distance will equal to v is 105 squared, because we have to square it, divided by 32 multiplied by sine 2 times 50 degrees. In other words, the distance is going to be 105 squared divided by 32 times sine 100 degrees. So I would like to make sure when you punch this problem in your graphing calculator, first hit the mode button on the calculator and make sure your calculator is in the degree mode, not in the radian mode. So now let us calculate this problem and find that horizontal distance. So the distance is approximately going to be 339.297 feet. Let's round this to the nearest whole number. So the distance is going to be approximately 339 feet that this golf ball travels. So I'm going to say rounded to the nearest foot. So you always round your answer depending on what the question is asking you. In this case, they didn't give us any kind of rounding, so I just decided to round it to the nearest foot. So your next slide is going to be your last monitoring progress problems in this lesson. So please make sure you work them out before you go ahead and look at your answers to check your answers.